Alright, this is part 2 of the trigonometry series of videos that I plan on making. And basically, in this video, we're going to talk about the different types of trigonometric functions that are actually that we utilize when we first started off learning trig. So, we're going to start off with the 3 most basic trig functions that we talk about. One of the basic functions is called sine. The other one, use a different color, is called cosine. And the last one is called the tangent function. So we got sine, cosine, and tangent. These are basically names for particular ratios that we set up when we're dealing with right triangles in trigonometry. And as in the last video, as I stated, when we use trig is when we have either 2 sides and we're trying to figure out a missing angle, or if we have an angle measure in just one side, then we start referring to how can we utilize trigonometry, because the Pythagorean theorem doesn't work then, basically. So, but I'm not going to go back to video 1. I'm just going to focus on this particular video. So, there's a little saying, and I'm pretty sure that you all hear it all the time, even if you're not in 7th or 8th grade, from Miss Redmond or another teacher. What these trig ratios, how do we remember them? So there's a little acronym that we think of. We use the initial letters of sine, cosine, and the tangent functions. We think of this as saying called so, ca, tor. So, ca, tor. When we think about, if you hear the sounds in so, it sounds like I'm saying O over H, like so. And for ka, it sounds like we're saying C A over H, ka. Okay, toa, T O A. So toa, O A. So ka, toa is the particular saying that we just say just to help us remember the trig ratios, and they'll carry you a long way through high school. So they really come in really handy. So with that said, let's actually look at a triangle and see if we can start learning some information about trig, or if I can teach you some information about basic trigonometry. Okay, once again, we know we're dealing with a right triangle. Okay, let's say for instance we had some angle measure. I'm going to put that angle here, and I'm going to call this angle 45 degrees. Okay, kind of look like a 45-degree angle, doesn't it? All right, well, and I'm going to put this symbol here, indicate it's a right angle. So if this is a 45 degree right now, but we're going to focus on what in the world is this O and this H, this A and this H, or this O and the A. Let's just actually just say it. So this O stands for opposite. I'm going to put OPP, the opposite side. The H stands for the hypotenuse side of a right triangle, in a right triangle. The A stands for adjacent side. The H once again stands for hypotenuse. The O once again stands for opposite side in the right triangle, and A stands for adjacent or next to, adjacent. Okay, so if we look at this angle right here, here's an angle here, here's an angle here, a 90-degree angle. And this is an angle as well, but we're given this one, so I'm just going to focus on this particular angle. Now, if we had, I'm going to call this X, I'm just going to call this Y, and I'm going to call this side Z. This angle here is called the reference angle. This is the angle that we refer to when we are trying to figure out what sides will be considered the opposite or the adjacent, and then even the hypotenuse sometimes. Okay, now this is the angle we refer to degree angle to figure out what sides are considered the opposite side or the adjacent side. But it can be used to identify the adjacent side. Exactly. We never use the 90-degree angle as our reference angle to figure out what side is considered the opposite side or the adjacent side. But it can be used to identify the hypotenuse. So across from, if we look over here, across from any 90-degree angle, you will see the side that is considered the hypotenuse. So I'm going to write the word hypotenuse here. Oftentimes we can identify it just by looking at it, but sometimes it can be kind of funny. All the sides can look like they're the same side length, and then it's hard to identify it. So it's important that you know opposite the 90-degree angle, it will be your hypotenuse. Now, let's use our reference angle to figure out the other two. If we look across or opposite from this 45-degree angle, we'll see the side that is opposite to it. So in reference to the reference angle, this side, X, is considered the opposite side. So let's put OPP for opposite side. Okay? Now, the last side cannot be the opposite side. It can't be the hypotenuse. It is the adjacent side. It is the side that is connected to the reference angle. So we always use the reference angle to identify our sides. In this case, opposite, look across or opposite to the reference angle is what we call the opposite side. In this case, it's X long. The adjacent side is always connected to the reference angle. This is connected to it, and this is connected to it. These are the sides that help form this 45-degree angle. But this side is the hypotenuse. This is the longest side. So the other side will be considered the adjacent side. Once you identify the hypotenuse and the opposite side, the adjacent side is pretty much obvious. All right. So with that said, let's go ahead and set up some ratios. So what would be sine 45 degrees? Let's say 45 sine 45 degrees would be what ratio set up? What sides would you put over what? Okay, what side over what side? That would be, the sine is opposite over hypotenuse. So that would be X over Z. Okay, so the ratio of X over Z is going to give us a particular angle length or angle measure. Okay, now what about cosine 45 degrees? We're just playing with learning how to set up trig ratios. X over Z is a ratio. It's a comparison of two sides. Cosine 45 degrees would be the ca, adjacent over the hypotenuse side. Adjacent side is the Y side. The hypotenuse is once again Z. So you have to put them in order. You can't put them in any order. That would be Y over Z. And the tangent 45 degrees would be what? The opposite over the what? Adjacent side. Opposite to the reference angle is X, and adjacent would be Y. So that would be X over Y. So the sine function or the sine ratio of 45 degrees is X over Z. The cosine ratio is Y over Z, and the tangent ratio is X over Y when we're looking from the reference angle. Okay, so I just incorporated or just input this little snapshot, and basically it's going to help us do a lot of problems way quicker. So let's actually figure out what the answer is to 1 through 6 real quick. So sine 45 degrees. So what side would be opposite sine? Okay, opposite over hypotenuse. So if we look at the sine angle if we look at the angle 45 degrees, opposite would be y. So sine 45 degrees would be y over, what's that, the hypotenuse? Obviously the hypotenuse is z. So sine 45 degrees would be the y side length or base over z, which is the hypotenuse. Cosine 45 degrees. Cosine 40 degrees. So our reference angle is still 45 degrees. Cosine is the adjacent side. Adjacent side would be to this 45 degree angle. It would be this side, wouldn't it? This would be our adjacent side. This, of course, let's just put hypotenuse here. Now, these two may change depending on what we're using for our reference angle. So I'm not going to put anything there. Cosine 40 degrees would be adjacent. That would be the x over the hypotenuse, which is z length. Okay? Tangent 45 degrees. The tangent ratio says we put the opposite side over the adjacent side. So we also looking from 45, this reference angle is 45 degrees. So the opposite side would be opposite to the 45 degree angle. We're looking across from here, which is opposite, would be y. Over the adjacent side, once again, x is still the adjacent side to the reference angle. Okay. Sine 55 degrees. Now this is telling us to look from a different perspective. It's telling us to look from the 55 degree angle, and now we have to identify what is considered opposite. Well, if we look across from the 55 degree angle, x is the opposite side. So we're going to put x over hypotenuse. Sine, S-I-N, is an abbreviation, of course, for sine, over the hypotenuse. The hypotenuse is z. Cosine 55 degrees. So our reference angle is 55 degrees. Cosine says put the adjacent side, which would be y in this case. I hope you all catching on. I think you all getting this. Y over the hypotenuse, which is z. Okay. Last but not least, the tangent function, 55 degrees. What would be the tangent ratio that you set up? Opposite over adjacent. Opposite, the x, over the adjacent side, which would be y. This is just small practice to get you ready to learn how to solve trigonometry problems. You may not understand why we set these ratios up yet, but you sure will in the next video. Talk to you all later. Bye-bye.